Okay, so now we're going to cover the other side of option valuation with the binomial method, which is the risk neutral method, which is the one I actually prefer. I feel like it's a little bit easier to grasp the concept here than the option equivalent method. So just consider the same information as before. We're going to cover the same exact example, which is the Google stock priced at $530. This stock can either go down to $424 or it can go up to 662.5. In either case, with a decrease, our call would be worthless. We would not exercise the call. In the case, the value of the call would be 0. In the other scenario, the upturn, as we like to call it, the other side of the scenario is the downturn. This is the upturn, the 662.5. The value of our call will be the difference between this stock price here and our stock price before, which is $132.5. That's the payoff of the call in this situation. We have our risk-free rate as 1%. So let's get into the risk neutral valuation and just go over one of the most important assumptions about the method that's important for you to really understand what's going on here is right here. It says all investors are indifferent about risk. So what it's saying is all of the investors, we're making the assumption that they all expect the same return on their assets that we're valuing. So we're going to assume that they just expect the risk-free rate of return, which in our situation, in this example, is 1%. So this is a critical piece of information that allows us to use the formula down here for expected return and set it equal to 1%. So the first thing you need to do in this risk neutral valuation is you need to calculate the return in an upturn and the return in a downturn. So in this first situation, we have, our stock can either go up to 662.5 or it can go down to 424. In the case of an upturn, we have our stock price is worth 662.5. So we take that number and we subtract the stock price it was at before, which is $530, and then we divide by the old stock price, and that will give us the return during that period on the option or whatever we're valuing in this case. So if you make this calculation, you'll determine that the return in this situation, or the return in an upturn, is going to be 25.25 or 25%, a positive 25% increase in the value of our option here. And then on the other side of the equation, we have a downturn, which we already know what's going to happen to our stock price. Our stock price will decrease to $424, and so we have our old stock price of 530, and we divide by the old stock price of 530, and our return in a downturn is going to be equal to negative 25%. So we can either have a positive 20% gain, or we can have a negative 25% gain. Oh, I'm sorry, negative 20. My math is off. So it's negative 20% for a downturn and positive 25% for an upturn here. Excuse the signs there. Okay, so we know that information. Now take a look at this formula here. The formula is the expected return of the risky assets is equal to the probability of an upturn times the return in an upturn plus 1 minus the probability of an upturn times the return in a downturn. So this 1 minus the probability of an upturn, that is essentially the probability of a downturn, because we have two situations here. It is the binomial model. So both of these fractions here, PU, or 1 minus PU and PU, are both going to add up to 1.0. So with that information, we can actually set this algebraic formula equal to 0.01, which is our return on the risk-free rate calculated above here. So let's go ahead and set that equation up. and I'll just show you how it works. So we have 0.01 equal to, we'll say y for probability of an upturn, times 0.25 plus 1 minus y times 0.20. Okay, but this is negative. And so what we can do here is you basically just multiply this out. So it would be 0.25 y plus negative 0.2 times 1 is going to be equal to negative 0.020 plus negative 0.20 times negative y will equate to a positive 0.20y. Sorry, I'm struggling to speak here. So you add the 0.20y to the 0.25y, and that will give you 0.45y. And keep in mind, all this is still equal to 0.01. So in order to get this off of this side of the equation, we would want to add this to the other side. So you add 0.20 to 0.01. That will give you 0.21, and that would be equal to 0.45y. So you just divide by 0.45y. Divide the 0.21 by 0.45, and you'll see that y is equal to 0.4666, repeating. So 46.66% roughly is the probability that an upturn would occur. And since we're using the binomial method here, we can make the assumption that we can actually calculate the probability of a downturn given this piece of information here. So in order to do that, we just take 1 minus 0.4666, and we actually get 0.5334, and that is the probability of a downturn. So I know this looks really, really disgusting, really, really messy. I'm going to clean it up a little bit and show you guys how, now that we have this information, we can value the call using the risk-neutral method. Okay, don't save. I need to take some time to breathe here and have a drink. Okay, so I'm going to write the information that we've calculated. We've calculated the return in an upturn, and that is going to be 25%, a positive 25%. We've calculated the return in a downturn to be a negative 20%. We've calculated the probability of an upturn to be 46.66% of the time. And we've calculated the probability of a downturn to be 53.34%. Now, we also know in both of these two situations, we already know the value of our, or the payoff of our call, or the value of our call, either one, the payoff or the value of our call in both those situations. And in an upturn, we know that our call would be worth $132.50. And in a downturn, we know that our call would be worthless because we wouldn't execute the call if the stock price was lower than the exercise price that we bought our call at. So with that information, we can actually use some of the valuation method, pretty much the same general method that we used back in chapter 20 to calculate the value of the call here. So I'll show you the value of the call in an upturn will be $132.50 times 0.4666, which is the probability that we would get this payoff from the option. And we're going to add this to $0, put a dollar sign here so you remember that it's a dollar amount, $0 times the 0.5334 probability of a downturn. And if you calculate this out, you will get the exact same number that we got before, in year two for the call, which is $61.83. And what we have to do now, just like we did for the last method, is we need to actually discount this value of the call back to the present. And that's really, really simple to do. We already know how to do that. We just take $61.83 and you divide by 1 plus the interest rate, which we know to be 1%. And that is to the power of t, which in this case is just 1 year. So if you do this calculation, you will get the present value of the call at t equals 0 to be $61.22. I know it's kind of hard to see, but you can see it right here as well, $61.22. The same exact value that we got up here for our value of a call using the option equivalent method. So I hope you enjoyed this video, just kind of going through some of the basics of the binomial valuation method. Is definitely the less complicated of the many option valuation models out there today. I didn't want to cover the Black-Scholes model in this video. I'll cover it in chapter 22 when I go over real options. So thank you guys for watching, and I'll see you next time.